Hello everyone, my name is Betül. On this video, we will solve a past paper question. So let's read the question together. It says, the placement in centimeters of a particle from an origin O at time t seconds is given by s of t squared times cos t plus 2t times sine t, and t should be between 0 and 5, and they are also included. Okay, in order to solve the first part, let's check. Question A. Find the maximum distance of the particle from O. Okay, in order to solve it, first of all, we need to focus on our Ti. On Ti, we will just write this equation, but be careful, on our Ti, we can just see it as f of x. So it means on the equation, we will just put x instead of t. Okay, let me write this equation on Ti. Let's check. Okay, we already know t should be between 0 and 5. Because of this, I can use, if I want, I can use a piecewise function. Let's start with piecewise function. First, click menu, then graphs. Then right now we will just select a piecewise function right here. Let's select this. And then I write my function as x squared times cos t, which is cos x here, of course, cosine x, then plus 2x, 2 times x times sine t, which is sine x. Okay, sine x. Okay, it should be between 0 and 5, and also they are included. 0 is less than or equal to, which is right here, x, and also less than or equal to 5. Okay, for the rest of it, we will just raise and bar delete. Okay, click enter right now. We identify our function graph, but I wanna see right here also. Because of this, I'll just make it zoom out. Okay, let's do this. Window zoom and then zoom out. Okay, click to the right part. I'll just come to the top of the graph. Then I'll click once. Okay, it's enough for us right now. Let me check. Okay, for displacement, right now this function already represents our displacement function, but we can see a maximum point and minimum point on this function. So one of them represents our maximum displacement. So I need to identify their y value on the given function. Let's do this. Click menu, then analyze graph. I'll start with maximum points. Okay, let's start. I can start from here to shade. So click middle point, then move to the right. Okay, it's already see the maximum. Click middle point. I can identify x will become 1.52 and y value will represent 3.15. So 3.15 might be my maximum displacement, but I need to also check the below part, which represent our local minimum points. Click menu, then analyze graph again. Then you will just move to the minimum points. Okay, I'll just move until now and let's start from here for minimum. It's already the same. We can see its coordinate. While x equals to 3.99, y value will be equal to minus 16.5. So when we check 16.5 and 3.15 in displacement, we will just use their absolute value. So 3 or 16, 3.15 or 16.5, which one is the greatest one? Of course, 16.5 will represent our maximum distance. So if you want to write these operations on your paper for IB exam, let's write them one by one together from here in order to get more place. So use the graph. This is our first part. Graph of, like you see here, displacements. Then we identify the coordinates for local max and local mean. Identify coordinates of, let me write local max and local mean. Okay, then compare their coordinates. When we compare their coordinates, we actually identify local maximum distance will be represented with local minimum point because it was 16.5 minus 16.5. This minus just represent their direction. So identify or find local mean as our maximum distance. Okay, so in this situation, I will just write RS for you according to TI. It's represented as minus 16.5. This minus, like we said, just represent the direction. Because of this, for question A, our answer for maximum distance will be actually equal to 16.5, and in the unit we can just see centimeter, we will just write centimeter. If it is also asking for the direction, we said minus represent our direction, so plus represent the right and minus represent the left. In this situation, to the left of point O. That's it. We can just write like this for the first question. For the second question, let's read it together. Find the acceleration of the particle at the distance it first changes direction. Okay, first of all, let's talk about the relation between this equation and then acceleration. If we just take first derivative for this function, we will identify their velocity. But we try to get the acceleration, so I need to get one more derivative, which means its second derivative will represent our acceleration. And in the question, it just say at the distance, at the instant, it first changes direction. Okay, let's check the graph. It can just change its direction on the local max point. So while moving to the right, it starts moving to the left part actually. So in this situation, I'm looking for the value of 1.52 while time equals to, let me write time here, while time equals to, oops, let me write it here, time equals to 1.52. I'll just check this, which represent x value according to this given function. So, first of all, let's sketch the graph of acceleration. Click menu, actually, before this, we can just click tab. Then we can just identify the second derivative from this graph. It will be easier. Click this button. You can see some option. We will just come right here. So you can see 2, which represent our second derivative for the first graph. Okay, when we click it, we are taking the derivative according to x. Click x. And we are taking the derivative of f1 of x function. Okay, click enter. Right now you can see the graph of acceleration, but I'm trying to get the exact value. Because of this, I'll focus on while x equals to 1.52. So I need to identify its table. Click menu, then move to the table parts. Split screen table, it works. Okay, I can see the table, but according to f1 of x function, I need it for f2 of x, which represent our, actually right here, which represent our acceleration graph. Click choose, then we will just select f2 function. And when we check x values, we can see integers, but I need 1.52, so I need to edit the table. Click menu, then table, then edit table settings. So it might start from 0. I'll click tab and table step between each value. I just want 0.01 in order to get 1.52. Okay, click tab, 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 and okay. So right now, let's move 1.52. Let's move down until 1.52. Okay, let's check our acceleration. at the instant for it changes the direction first time. Okay, right here we identified. So its acceleration, like you see here, will be equal to minus 8.92 when we just round it to the 3 decimal number. So in this situation, we can just say, in order to write all this operation, be careful, our answer is already given as minus 8.92. So let's check down one by one. Let's write it. Okay, let me write for question B. First of all, we identify the maximum point, local max point, first maximum. Identify first maximum points, coordinates of it. So from this coordinate, we identify t value. Okay. Identify t value from first maximum points. Then, after we identify this t value, actually we just use acceleration graph. Okay, then use the graph of acceleration. Let's write it. Use the graph of acceleration at this t value. So at t equals to 1.52. Okay, then we identify our acceleration as minus 8.92, which represents our acceleration at the instant it first changes direction. So we can just write directly a of t, which represents a of 1.52, represent minus 8.92. Be careful, in the unit we were just using centimeters, and right now and in the seconds, of course, in time. So our value will be equal to our unit centimeter over second square for the acceleration. Okay, this will become our answer for this question. Thank you for watching.